In this video, we're going to talk about another kind of division. It's called synthetic division. And we're also going to look at using that for something called the remainder theorem. So in synthetic division, it is a different type of division than long division. And so to find the quotient and the remainder when a polynomial of degree 1 or higher is divided by x minus c. A shortened version of long division can be used, and that's called synthetic division. So it is shorter than long division. So here is kind of a visual of the long division that we've done before, okay? And so when you're dividing, right, we've got our dividend, our divisor, then we get our quotient plus the remainder over the divisor. And so this is just a shorthand way of doing that, but it only works when you have just something like this. So x plus a number or x minus a number. Okay. So let's kind of look at what happens here and how synthetic division works. So if we're dividing by x plus 1, okay, we need to think of that as the form x minus c. And so what that means is that c is negative 1, okay? Because basically, if I was trying to solve for x, right, x would equal negative 1. And so that's where we're going to get that c from. So when I am setting up my synthetic division, I'm going to set it up with this box in my corner. And so in my corner box, that's where I'm going to put this c value. And remember, easiest way to do it, easiest way to find that, okay, is to take this, set it equal to 0, and solve. So we can subtract 1, and that's where we can get that. So I'm going to put that in this box, okay? Now, the other trick to synthetic division is that we're only using the coefficients. We're not using any x's. Okay, so I've got this negative 1, move it down just a little bit, and then I'm just going to use my coefficients. So the coefficients here, right, I've got this first term, the coefficient is a 1. Let's start there. Then my second term, the coefficient is a 3. Then my last term, negative 2. Okay. So the negative 1 in the box comes from this, which comes from here. Then 1, 3, and negative 2. Right now, we're going to draw a line. Then that's our setup. Now we start solving. Okay, so here's how it works. First thing we're going to do, we're going to drop down that first number. The only operations we use are multiplication and addition. We're going to multiply this by this. So 1 times negative 1 is negative 1. Then we're going to add these two. So 3 plus negative 1 is 2. Then we do that again. We multiply 2 times negative 1. We get negative 2. Then we add negative 2 and negative 2, and we get negative 4. And that's it, we're finished. That's synthetic division. Now we got to make sure we understand what each piece is. So these right here represent the coefficients of the quotient. This is the remainder. So that means that if I started with x squared in my division, it drops by 1 exponent. So that means that if my coefficients of my quotient are 1 and 2, and I started with x squared, then it's going to be 1x plus 2. So 1x plus 2. Those came straight from there. Okay. The minus 4 is my remainder, so I'm going to do plus the negative 4 over x plus 1. And you would have gotten the exact same thing if you did long division. Right, let's get a couple of more. Okay, so before looking at the synthetic division, you want to make sure that everything is in descending order. Okay, so we just want to make sure that our variables are all lined up, just like we did with long division. We also want to make sure we're not missing any power. So if we are, we've got to have those 0 placeholders, just like we did in long division. Okay. All right, so let's look at example 1. So again, I'm going to find that number that goes in the box. Easiest way to do that is to take this, set it equal to 0, add that 6, that means it's a positive 6, and that goes in the box. Okay. Beside the box are going to be my coefficients. So this is a 1. This coefficient is a 3. This is a negative 54. Those are going to be the values that lead beside it. So 1, 3, negative 54. And that's my setup. Now we solve. So drop down the 1. Remember, we multiply 1 times 6. Then add 3 and 6. Then multiply 9 times 6. Then add negative 54 and 54. This number is the remainder. These 1 and 9 coefficients. So that means that if I started with x squared, this is going to be 1x plus 9, no remainder. Much quicker than long division. Okay. All right, same thing here. Okay, I'm going to take that. I'm going to say, all right, well, I need to know what goes in the box. So x equals negative 9. These are going to tell me my coefficients. So 1, 6, and negative 25. So if I set that up, right, I've got in the box a negative 9. I've got 1, 6, and negative 25. Now I just need to add and multiply some stuff. So I'm going to start by dropping down my 1. Then multiply, add, multiply, and then finally add. The last number is always going to be your remainder. So I get 1x minus 3. Since I have a remainder, I'm going to do plus the remainder over x plus 9. Right, more. So again here, I'm going to say, all right, this is x plus 3. So x equals negative 3. That means that goes in my box. So negative 3. Notice this one goes from x cubed all the way to just 27. So I've got some missing place values that I need to take care of. So I'm going to have a 1 for x cubed. I don't have an x squared. I don't have an x, and then my constant. Okay, so again, this is the x cubed, x squared, x, and then constant. So we've got to have those place values there. Okay. All right, then, with my line, and then we start. So I'm going to drop down the 1. I'm going to multiply 1 and negative 3. I'm going to add 0 and negative 3. I'm going to multiply negative 3 times negative 3. I'm going to add 0 and 9. Multiply 9 and negative 3. Then I'm going to add 27 and negative 27, and I get 0 for my remainder. Now remember, they drop by 1 exponent. So if I started with x cubed, this is going to be x squared. So 1x squared minus 3x plus 9. One more. Okay, it's okay that it's a fraction. Same idea. We're going to take this. That means that it's going to be positive 1/2 in my box. So I've got 1/2. Put my exponent, or my coefficients. 2, 11, 12, and negative 9. Be careful, always make sure you get the signs in there too. All right, so we're going to start by bringing down the 2. So 2 times 1/2 is 1. Add those up and I get 12. 12 times 1/2, 6. Add those up, I get 18. 18 times 1/2, 9. Nice 0 remainder. Again, it drops by 1 exponent. So since I started with x cubed, that means this is going to be 2x squared, 12x, and 18. Right. And I've also got a sheet similar to the long division one with synthetic in here. Just kind of marks everything out. So if you forget when to add, when to multiply. So it's a pretty nice just reminder with everything in there for you. So again, you can print this out or you can write it out in your notes. The last thing we want to look at in this video is the remainder theorem. So the remainder theorem says that if a polynomial p of x is divided by x minus c, then the remainder is p of c. So basically what that means is if you divide, just like we did with synthetic division, right? The remainder is going to be the same as whatever you get by plugging in that same c value. Okay. So let's look at an example so I can show you what that means. So it says use the remainder theorem and synthetic division to find p of 4. Okay. So first thing we're going to do is we're going to use synthetic division. So what the remainder theorem tells us is that when it says p of 4, right, the remainder theorem says, hey, if this is the 4, that means that this is my c. Okay, because you see the word remainder theorem. So that means that in my box, right, I'm going to have 4. And then I can come through and I can put my coefficients. So 1, negative 1, negative 2, 4, 3, 2. Hey, I don't have x, right? So 0 and 1. And I like to just go back through and count, right? So there's a 4, third power, second power, first power, and no power, right? All right, so I'm going to draw my line. Then we can start working. So drop the 1. 1 times 4 is 4. Add those together, I get 3. Multiply 3 and 4, I get 12. Add those, I get 10. Multiply 10 and 4 is 40. Add 40 and 0 is still 40. 40 times 4, 160. Find those, it's 161. All right, so now let's talk about what is all this, right? So this we know is the remainder, okay? So the remainder theorem says that the remainder is going to be the same thing as if I were to come up here and plug in 4. So if I were to come up here and just say, I want to just plug in 4 and do 4 to the 4th times minus 4 to the 3rd minus 2 times 4 squared plus 1. And now we're to put all that in my calculator. Guess what we'd get? 161. The remainder, is going to be the same as the value you would get by plugging in that number, okay? So, if we saw this, and it says use the remainder theorem to evaluate, okay, we have 2 options. We can, option 1, put a -5, do all that work, okay, find our remainder, or option 2, evaluate that. Option 2, quickest, right? That's the whole idea. That's the point. So if I did option 2, right, that's the point of this theorem. If we did that and we worked all that out and we put that in our calculator and it says, okay, P of -5 is going to equal -89. What does that tell us, right? That tells us that yes, when I plug in -5, I get -89. But what that also tells us is the remainder, okay? The remainder, when you take -2x squared plus 7x minus 4, and you divide it, right? Well, if it says c is -5, that means it would have been x plus 5. By that, your remainder would be -89. Okay. All right, last one. Here, again, if we're evaluating, we're just going to find P of 2. We're going to plug that in our calculator, and we get 1. And that's the remainder theorem.